Hello everybody, and welcome to exercise 2. And in this exercise we're being asked to calculate some indefinite integrals, which is basically just asking us to find antiderivatives of functions. And you might notice from the instructions in this problem it's suggesting that we use the technique of U substitution to do these problems. Okay, and remember the general point of a U substitution is to take a relatively complicated integral like this one, x squared times x cubed plus 1 to the 10th, and to transform it to an easier integral that we can do just by using our basic formulas for antiderivatives of functions. Okay, so the idea of this technique is to start by making a choice. We want to choose a u. You might remember that one of the general guidelines we talked about is to choose your u to be a function that's inside of another one. So kind of a natural choice to try in this case is u equals x cubed plus 1, okay, because it's inside that 10th power. After you've chosen your u, the next step is to take the derivative, the differential of that u. So the derivative of x cubed plus 1 is 3x squared, tack on a dx. And then we're going to solve that for dx by just dividing both sides by 3x squared. Okay, and those are kind of the starting steps when you do this. All right, and the idea is now we're going to substitute into our integral and try to rewrite it in terms of the variable u. All right, so if we start, just rewrite the x squared, and then the x cubed plus 1, we gave that a name. We called it u, so that becomes the u to the 10th. And then if you look over here at our work, dx is equal to du over 3x squared. Okay, so we're going to go ahead and substitute that as well. Okay, and generally what we hope for is cancellation in this case. Notice that we've got an x squared in the numerator and the denominator, and so those cancel. And that's generally a good sign when that happens. You can get all of your original variable to go away. That's a sign that you probably made a good substitution. Okay, and rewriting what's left over, we might notice that there's this 3 in the denominator. That's a constant, and so we're free to pull that outside of our integral. Let's do that. And what's left over inside is just u to the 10th du. Okay, so notice that we've taken the integral that we started with over here that was pretty complicated, and we've transformed it into a much easier integral, u to the 10th du. And so what that's asking us to do basically is just find an antiderivative for the function u to the 10th. We can do that using the ordinary power rule. Okay, so if we take u to the 10th and find an antiderivative, we're going to get u to the 11 over 11. This is an indefinite integral, so there's a plus c on the end. Okay, and we can simplify that a little bit. There's a 3 and an 11 in the denominator. We can put those together into a 1 over 33. And then there's one more step that we want to do. We'd like our answer to be in terms of x, since that was the variable up here in our original integral. So we'll just go ahead and substitute the u back in. Okay, and so our final answer just looks like 1 over 33, x cubed plus 1 to the 11th plus c. There's our antiderivative.